time zone you're in. My name is Peter Stansky, and I've got the opportunity to spend an hour with you to talk about cloud migration and how to do it. This presentation specifically focuses on application developers, and the intention is to give you some appreciation and understanding on how to plan, as well as how to attempt a cloud migration from your on-premise. The agenda of this session today will last about 45 to 50 minutes, with the remainder of the last 5-10 minutes being left aside for some questions. Having said that, throughout this session, please ask questions in the chat window, and the fantastic team that's supporting me will be able to answer some of those questions. Moving forward into the cloud, I'm also going to cover the various migration patterns that you may wish to consider as a part of your transition from on-prem over to the AWS infrastructure. As well as I'm going to walk you through some of the Amazon services and options that are available to you as a part of that transition. We have a number of services that you can potentially use today and also moving into the future as your maturity improves and understanding of the Amazon services, whereby you can actually automate a great deal of the activities that you currently may be doing by hand. So let's kick off. We've seen a number of customers move over into AWS from a traditional infrastructure. We've actually found that there are quite a common number of steps that one needs to follow in order to actually make a successful transition. I've got 6 points here which actually highlight the 6 major activities that one should think about as you migrate from on-prem into the cloud. Starting on the left, our customers often start off with a cloud assessment phase. The intention of this is to assess the costs for running on AWS, assess the Amazon services and potentially your architecture and any changes, if any, required to your current applications, as well as looking at the Amazon security stature, better understand how we comply with regulatory compliance, go through our PCI or SOC compliance levels or ISO compliance to better get an appreciation of the security that you're going to experience by being part of AWS Cloud. Moving on from that, quite often customers embark on a proof of concept. The idea here is to learn about AWS services, roll up your sleeves and deploy a pilot application. Get comfortable with how you would deploy or run the application in readiness for potentially transitioning a larger fleet of infrastructure over to us, as well as having a closer look at your existing processes and adjusting those and understand what implications there, if any, there are going to be to your traditional business as usual operations as well as deployment practices. After that, you often tend to look at the data side of things. How do I move my data from on-prem into the cloud? This is a major activity for a lot of organizations because over time, data grows to very large scale. And it can also become a challenge to migrate, petabytes of information from one location to another. So at this phase, customers often look at the number of scenarios where you can use Amazon to gradually move your data from your data center into AWS, using us for DER as a gradual migration, or doing a bulk import. It really depends on the kind of data and the systems that you have. But there's one thing to remember, data has gravity. Wherever data goes, so do applications, which is the next phase. If you look at the application migration phase, you may consider doing a forklift migration, whereby you pick up your infrastructure and rapidly move it into AWS. You can certainly do that, and a lot of customers have done that. But you may also consider doing a hybrid migration, whereby you maintain your existing facilities, your data centers, but you gradually migrate at a particular rate that's suitable to your business requirements over into the AWS Cloud. So you might end up with a hybrid strategy and potentially a forklift strategy for some systems that require rapid migration. After that, once you've moved your workloads into AWS, you may wish to consider using some of the built-in features such as auto-scaling and automation and elasticity features of the cloud to enable your applications to be perhaps more available, highly reliable, or perhaps be able to cope with very bursty workloads, which traditionally you might have had issues with on a traditional infrastructure. Once you've done that and you've gotten really good at understanding and operating your platform, your solutions on AWS, you will then probably start to look at optimization, looking at how you can turn off unused infrastructure, perhaps look at using more efficient ways of consuming compute, looking at how you can optimize performance by selecting different size virtual machines, as well as potentially looking at re-engineering of some of your architectures in order to take advantage of cloud design patterns. So all of these steps we've actually documented in a white paper, which is available here. And the migration approach is covered in far more detail than I've covered up here, but these 6 major steps are the key component of your migration strategy. For this presentation, I'm going to go through step 4 and 5, which is around application migration and how to leverage the cloud. I'm going to show you some services that might potentially help you in that transition. Before we do that, it's important to understand what are the candidate target applications and systems you wish to move over to AWS Cloud. Quite often, these tend to be spiky workloads, which tend to often be web applications, where the load goes up unpredictably, and it's very difficult to sometimes cope with spiky workloads on traditional infrastructure, where you always have to provision for maximum capacity. In the cloud, you provision for what you need. So you have more infrastructure running at peak loads. When it's off-peak, you can turn off the infrastructure that you don't need. Also, dev test and associated environments are often great candidates to move into the cloud early, because a lot of these systems are non-production. Dev test also experiences a great deal of changes. There's a higher frequency of change in dev test environments than there often is in production. So they're great candidates for moving into the cloud, because there's often no business disruption as a part of that migration. Also, systems like grid computing, 3D rendering or image rendering applications, analytics are great where there is a need for bursty amount of compute. We need a lot of compute cycles to do calculations, but you only need them for a couple of hours a day. These are fantastic candidates for early migration targets. Having said that, one of the other challenges that you may also be dealing with at the moment is an explosion of data on-prem. You might be running short of disk storage, as well as looking at other novel ways to reduce your backup and archiving options at a low cost, as well as potentially exploring situations and scenarios for application disaster recovery. In some cases, I've had customers who've migrated the applications in a disaster recovery state into AWS and failed over to AWS when the need arose, never failing back to on-premise systems. Before you also move into the cloud, as a part of your assessment, you also need to understand the shared security model that Amazon believes in. So let me explain it for a second. If you look at the AWS Cloud, Amazon is responsible for the security of the cloud, which means responsible for our facilities, regions, maintaining our SLAs, and giving you continuity of service because you rely on that infrastructure. So we take care of all those aspects and elements. In terms of your responsibilities, when you bring your workloads to AWS, you are responsible for the security of the cloud. In the cloud. In the cloud meaning of your applications, the patching of your operating systems, making sure that the systems are patched, configured correctly and accurately. Because AWS literally stops at the virtual machine hypervisor. So our services provide their level of SLAs, and then you in turn consume those as a part of your architecture, as a part of your application. So what are we trying to achieve? In fact, when you make a migration into the AWS infrastructure, you're looking for extending your on-premise resources and integrating those with cloud computing resources in AWS. In order to achieve that, you do need to have network connectivity. So you have a number of options here. When you spin up your infrastructure in AWS, you can connect to it over the open internet, or you may choose to connect to it via a virtual private network, a VPN. In fact, we have some customers who also proceed one step further and go and commission a leased line from a telecommunications provider. And so we also allow what we call direct connect into AWS infrastructure from your on-premise data centers, which means you will get a leased line, most likely a fiber optic link in 1 gig to 10 gig or multiple thereof connectivity from your provider, and you can terminate that inside AWS, which means this allows you to maintain existing compliance with a lot of your existing systems, leverage previous investments, as well as enable yourselves to maintain interoperability with legacy systems that may not be able to move into the cloud. So as you make that transition, a couple of things to think about. You may wish to move an entire application in a single go. So as an example, what you may attempt to do is move an entire app that is self-contained. So imagine the application consisting of a web tier, middleware, as well as a database. In scenarios when you can do a complete lift at the same time from on-prem into the cloud, that becomes one of the easiest transitions. You can do that one application at a time or do it in groups or clusters. We call this a vertical migration. A number of customers will do this for most likely smaller applications. Applications that are self-contained and they're essentially an atomic deployment unit and are also well understood. So the sociability between other applications is also understood so that as you make that transition from one location to the other, hopefully there is no disruption of service to the business. Another approach perhaps could be that for more complex applications which are made up of a number of tiers, you may wish to take a gradual approach whereby you may actually move a part of that application first, such as the application web tier in this context. Which means if you have a very bursty workload that is essentially hard to predict, you may find that moving that tier into AWS will be quite beneficial, because if you can apply elasticity to the web tier, when the capacity and demands are high during peak times, you can scale out and meet those demands. And at off-peak periods, such as in the evenings, you may be able to scale down your applications potentially down to one server from 100. You may then find that it makes more sense over time to then migrate either the middle tier or other tiers at the same time into the cloud and leave the very heavy, gravity-centric database sitting on premise. Having said that, you also need to be very mindful. You need to understand the application's architecture as well as its latency requirements. Because if you are doing a lot of transactions in the actual database engine, you will find that the middle tier may become very chatty. So it would be fantastic if you could actually, over time, move your database over into the AWS Cloud as well. And there are a number of options here. You could certainly try to move the database over a weekend or during a scheduled outage period that's been agreed with the business. Or you may actually try to trickle that data from on-prem into AWS, as in the case of a VR scenario, and then flip the switch from on-prem to the AWS copy of your data and maintain, hopefully, zero downtime as you make the transition. Again, for large, complex applications, it's very important to have a closer look at all the tiers, as well as any external application dependencies. This I refer to as the horizontal migration, because you've moved tier by tier from one to the other. Now, let's have a look at how you may actually attempt to do this. But in order to do that, you also have to understand where your scope of responsibility lies. So I wanted to call out to have a consideration of what your role as a developer in this context happens to be. In some organizations, you might be a developer or a coder who is predominantly focused on working on your application. And depending on the structure of your organization, you may have very little to do with the actual infrastructure that your application runs on. It might be very much a hands-off model where you develop the application and ship it over to the operations team who take care of keeping the lights on and deploying your application. In some scenarios, you might be lucky and have the opportunity to be light on involved. So with the deployment onto the infrastructure that your application will ultimately be running on. But again, it depends on a great number of organizational factors that you need to consider. In case of being perhaps a software engineer or an architect, you might be allowed or have the responsibility or accountability to be more intimately involved in the application components, which means that should there be a need to change or improve or engineer and jump under the hood to get maximum solution performance, you might have that permission from the organization. So you might be able to touch and have great intimacy with the underlying infrastructure. And more recently, there's been a huge development in automation, and in terms of developer-owned operations coming together into a DevOps model where perhaps the applications are more like, the app developers are more like infrastructure engineers, and infrastructure engineers are more like application developers. So that line's becoming more and more blurred. So you may find, this could be you, whereby you're more heavily involved in continuous integration and continuous deployment, whereby you check in your code into a source repository that gets automatically picked up by a continuous build server, which then potentially ultimately deploys your code into the production environment or dev test environments, provided your code passes all of the scaffolding and all of the particular code coverage tests. So this essentially means that those engineers who automate everything and anything possible for maximum velocity of change could potentially be far more involved with the infrastructure than the coder developer who potentially is held back from being able to operate or control the infrastructure the code is running on. So ask yourself, which of these three are you? Having said that, within that context, here are 4 Amazon services that you could look at as a part of your migration. So the first is the Elastic Compute Cloud, which is essentially Amazon's core compute service, whereby you spin up virtual machines just like you would traditionally, except they're running in the cloud and have a programmatic API for configuration of firewalls. You can launch 1 or 100 of these at the push of a button if you use the Amazon Web Console or programmatically. We have another option which is called Elastic Beanstalk, which is essentially an application container. This is great because it lets you take an application that you've been working on, provide a configuration to the service, and Elastic Beanstalk will take your application package and deploy it into the Amazon infrastructure without you having to really needing to understand or deploy things like load balancers and auto scaling groups to scale out your application tiers and also potentially deploy databases at the same time. Moving on from there, you've also got another service which also abstracts the infrastructure, and that's called OpsWorks. It's essentially around application automation, whereby you as the developer or the architect or the engineer, you can configure your application environment to be configured of a number of tiers. So a web tier, a load balancing tier, a data tier, or a middleware. All of that which you can control yourself. And finally, you can dig really deep into the infrastructure and use what we call CloudFormation, which is essentially a way of templatizing and provisioning your environment. And when I say that, I mean you can provision everything from an IP address to the virtual private cloud, which is your own virtual data center on Amazon, to DNS records, to auto-scaling groups, databases, and almost everything that you can click on or call through an API, you can templatize and make repeatable. So if you're a developer or a coder, you're most likely going to be attracted to the first 3. As a DevOps engineer, you might like to start off in the plumbing and make your way up to the applications, but potentially you could be spread across the entire 4 services. And finally, as a software engineer or an architect, your skills and your requirements may need to vary, whereby you need to dig deep and optimize either do-it-yourself virtual machine configurations or the entire data center configurations and environments through CloudFormation. So you have a number of options that you can actually adopt and use. So let's focus on the Elastic Compute Cloud. This is essentially a do-it-yourself application deployment in a virtual environment. When you have a closer look at that, we have a number of virtual machine, as we call instance families. So a general purpose family, the M1s and the M3s, potentially the T2s, are a great combination. They're a great sweet spot whereby we give you a decent amount of memory, a decent amount of I/O, and a decent amount of CPU cores. So it's a great sweet spot. However, you might find that your applications may be more computationally intensive. So you might choose the compute optimized family, the C families, and the C families essentially give you the ability to have a large number of compute cores, but not necessarily a great deal of RAM. If you're using voice over IP applications, you might find there's a lot of CPU intensive activity, but not a great deal of RAM being consumed. Conversely, you might find you have applications that do require a great deal of memory, be it for caching or for database application purposes. So you may find that the memory optimized family is even a better choice for you. Or if you're running very large data warehouses or data sending applications that require a lot of storage, you may choose the storage optimized family, whereby you can attach a great deal of storage to those virtual machines. And again, another option would be the GPU family. If you're doing any graphical processing, image rendering in real time, Bitcoin mining, you may actually have a closer look at the GPU family of instances, as well as the micro family, which are essentially there for experimentation purposes. So as you can see, there's a large choice. And when you make a selection of a virtual machine that's suitable for yourselves, for your application, have a closer look at whether it's pegged at the CPU, whether it's pegged at memory, or it's pegged at the I/O. And depending on those 3 elements, you should pick that particular family. And just for a little bit of context, I thought it would be a bit of fun to show you how the EC2 virtual machines have evolved over time. As you can see, from 2006, we have come a very long way. And if you actually quickly add up those numbers, we have over 40 different types of virtual machine configurations spread across those various EC2 compute families. So it's a large number, and it's always growing. In fact, we've just recently announced the C4 family, which is, again, based on the latest hardware from Intel. And it's been announced, and it'll be available to you shortly within the next few weeks. So that was that. That was you doing it yourself on virtual machines, just like potentially you're doing today. You may now want to have a closer look at the application container model. And this is where you take your packaged applications, you pass it over to AWS, and let us take care of providing you a managed runtime environment. So let's have a closer look. So if you happen to be a .NET developer, a Java developer, Python, Node.js, Ruby, or a PHP developer, as well as someone who's already using Docker to potentially package your entire environments, which could be quite a hybrid combination, then you can certainly use Elastic Beanstalk. The idea here is that you would take a package application, such as quite often zipped up in a zip configuration, and what we do is we provide you with a host environment, which is a virtual instance, and we would then provide you with the operating system, a language interpreter, and the web server itself. As well as the application services associated with the application, and on top of that, we would deploy your package application. So this could be Node, Java, PHP, or potentially a Docker environment, a Docker container, which already has a lot of the application dependencies contained on your development machine or your environment you're using today, and shipped straight over into AWS. So that's the deployment model. What that actually behind the scenes will create is essentially an elastic load balancer, and this all depends on the configuration that you selected. We will then create an elastic auto-scaling tier of virtual machines. So this is already you jumping ahead and saying, I'm going to make my applications elastic and make them already cloud-friendly, and then wire all this up with potentially a DNS record via Route 53, which is our service for providing DNS resolution, and tie it back into the environment. The wonderful thing about this configuration is that you can make changes to your application's configurations and recompile the application, and then you can redeploy it via Elastic Beanstalk. And Elastic Beanstalk will make those changes and redeploy the code to all the machines that have been deployed that run your container, and will refresh from the current version to the next version that you've provided us with. In fact, you can combine this with a lot of other environments, so you can have multiple parallel Elastic Beanstalks, or you can have a number of versioned environments and change between themselves. In order to make this even simpler, while you can do all this via the web console, via programmatic APIs, we've also provided integration into Visual Studio, so this is Microsoft Visual Studio, as well as Eclipse environments. The screenshots I've got here are for Visual Studio. As you work on an application, you can right-click on your project, both in Eclipse and Visual Studio, and you will go through a deployment wizard. In this case, the wizard is asking me, what would I like to deploy? I would like to deploy my application into the US East region. I would like to use Elastic Beanstalk as my model. It then guides me through asking me about my application name, a description, as well as a version build of my environment, which are very useful. By the way, you can also integrate Elastic Beanstalk with Git. So if you are already using Git for source control, again, you can programmatically use the command line tools, just like you're checking your code into Git to do a Git push into AWS and deploy your code automatically into the Beanstalk environment. So that's another option. We then go through a few more questions and a few more comments. Here you are asked and prompted for an environment URL. So we'll give you an environment URL of your choice, provided it's not taken by anybody else. But again, you could also wire this up to your own DNS records. We're going to ask you for the kind of operating system you'd like to run, the kind of virtual machine instance you'd like. In this case, I'm choosing a micro, as well as asking me for a particular version of the runtime for ASP.NET. It also prompts me whether I would like to have a database provisioned. So Amazon also has another service called RDS, and RDS stands for a relational database service, whereby you can select from Microsoft SQL Server, Postgres, Oracle or my SQL database engines. It asks me for the final confirmation. It then will package my application and deploy it into the environment. And in approximately, in my case, in about 7 minutes, I have a completely auto-scaled environment sitting behind a load balancer with a database being healthy and accessible via the example app environment.beanstalk.com URL. And that's all it takes to deploy a brand new application inside AWS. So hopefully that gives you some perspective onto the amount of effort, or rather lack of effort, to migrate some applications. Now, Beanstalk is great, but not necessarily for everybody. Everyone's got different needs. This is where potentially OpsWorks comes in. And the idea of OpsWorks is to, again, take your application, design it tier by tier, and make it readily deployable on AWS. Now, in this case, OpsWorks also supports additional scripting and configuration of the environment. So if you've already happen to have made an investment in Chef and Chef recipes, you can bring your Chef recipes to OpsWorks and integrate them into your application deployment. If you haven't used Chef or you've never used it before, don't worry, you don't actually need to know anything about it, as Amazon provides you a large number of recipes already for the environment configuration. So let's have a quick look at the OpsWorks primer. What is it and how does it work? The terminology around OpsWorks is a little bit unusual. We talk about stacks. A stack essentially is an environment, whether it's production, dev test, staging, or something else. We refer to it as a stack. A stack is then configured from a number of layers. Think of a layer as a tier of the application. Be it your load balancing tier, your web tier, your middle tier, and your database tier. So you design those. You then can take your application and simply pass it over to OpsWorks, where OpsWorks will take the code and associated assets, as well as any additional recipes you'd like us to run, and then deploy that into the environment into a known configuration. And then, once that's been deployed, because you can also deploy things within auto-scaling configurations, we will then scale the environment or those tiers for you, depending upon your configurations. In fact, we can also turn tiers on and off at predetermined times, which can also save you, spending money unnecessarily. So at the heart of the OpsWorks service is fundamentally the service itself and a very small agent running inside the EC2 instance, inside the virtual machine, that is essentially Chef solo running on that particular instance. And it talks to the OpsWorks service. It talks to it, and they communicate between each other at various steps. They can talk to each other at setup, at configuration, at deployment of your application and code and any other assets or resources that you require deployed to a particular instance in a particular tier, as well as you can also roll back and undeploy a component, an application, or a configuration, and also have hooks into a shutdown behavior for your environment. So what do you end up with? Something not too dissimilar to that, whereby you create a number of tiers inside a stack, whereby here you've got a load balancer, which will be flicking traffic between the 3 Java application servers, which all then connect to a MongoDB tier, whereby you've got a master node and 2 read replicas. So that's OpsWorks. Another example of trying to automate the environment and configure it is through CloudFormation. Here, it's a very interesting model because a declarative configuration for your entire virtual data center, whether it's your entire architecture, applications, operating system, deployment scripts and boot scripts, databases, as well as you can control and configure other Amazon services such as DNS records, load balancers, create storage services, storage through another service called S3, Simple Storage Service, and a raft of other things. So essentially, it's a great way for DevOps engineers and architects and engineers who are so inclined to configure out an entire environment in a template. This is very commonly used by DevOps. So what's behind CloudFormation? So CloudFormation fundamentally is made up of a template, which is really nothing more than a text file. In fact, it's a JavaScript object notation template. What you have defined in are parameters, resources, and configuration actions. And depending how you wire these up, you have different side effects. So you take this file, you throw it and provide it to the CloudFormation service. The service will take that template, inspect it, and commence the creation of stacks. And at each phase, it'll provide you visibility into, I've just created a instance. I've now created a load balancer. I've now created the next service, and so on and so forth. And should your configuration be potentially incorrect, you will see errors, and there's a critical error, and you've chosen to do a rollback on error, it'll also uninstall the entire set of infrastructure that it has deployed. So it's created 10 servers, it'll delete those 10 servers and wind back the stack, as we refer to it. Hopefully, if everything is successful, you will end up with a fully configured stack, which has essentially everything wired exactly as you described it in the cloud configuration template. The interesting thing about CloudFormation is that this is not a static asset. You can go back to the original CloudFormation template, make some changes to your JSON, and then reapply it against CloudFormation. And then CloudFormation will compare your current template with the template it has deployed before, and it will compare the differences. And depending on the differences, if you've added perhaps another tier to your architecture, it'll go away and create that tier in the configured environment. If you did the opposite, if you've taken away some configurations, then it'll delete and remove those assets that is selected to be removed. So it becomes a very powerful mechanism for the creation and recreation of multiple environments. In fact, lots of our Amazon customers use CloudFormation to create production environments multiple times. Production environments that look identical, except one is used truly for production, and the other production identical environments are used for dev, test, training, whatever the requirement happens to be. In fact, if you also wanted to migrate between regions, so you're launching an environment in, say, in Sydney, and you wanted to migrate or create an exact duplicate environment in Singapore or Tokyo regions, you certainly could take the same CloudFormation template and with very small amount of changes, redeploy the entire environment in a foreign region. So what does this template look like? So JSON is fairly straightforward. There's not a lot to it, and here is a sample script that I've written in the past. This essentially creates some variables and some descriptions, which are referenced further down in the stack, in the script itself. But to give you a better example, just to drill in a fraction, you can have parameters. So parameters are very useful because if you are going to have this template deployed via CloudFormation, you may actually want to make small changes to that environment. As an example, for production purposes, you may want to change the maximum number of virtual machines you want to scale elastically to. But if you're doing this for dev test environments, you might want to have a single instance, a single virtual machine that doesn't really scale up or down. You just want to do functional testing on that. So by using the parameters, you can actually provide any number of user inputs. And if you run this template through the Amazon Web Console, as shown here, you will be prompted for any parameters that are required as a part of this template, which is a fantastic way of building a user interface and very quickly deploying environments. Furthermore, what if you wanted to deploy a database? Well, you could leverage the Amazon RDS service, so the database as a service, in this case, for Microsoft SQL Server. So as you can see, I'm allocating 20 gigs of storage. I want a backup retention of 1 day. I'm going to run it on a very small T1 micro baby-sized virtual machine, and I'm going to use the Microsoft SQL database engine. And I'm going to also provide an administrator username and password. And I'm going to have ports open for connectivity. In fact, if I want the changes to Postgres or Oracle or MySQL, it's merely a small configuration change to the database engine and a couple of ports. A lot of this stuff is identical between the various engines, which again makes deployment very, very quick and easy. So if you can invest a bit of time in creating CloudFormation templates, you can rapidly provision environments in AWS. So the benefits of CloudFormation are numerous. Well, you can programmatically create a template, so you can have a system that automatically generates a template and then creates an environment, which now allows you to treat the Amazon cloud as infrastructure as code. You can take this configuration and share it with somebody else. Or you may want to take this configuration and place it along with your code in source control, which means when you check in your code, you can also check in the configuration of your entire data center as a part of that release or that branch or feature release. It also gives you great visibility to the known configuration. You can look at the CloudFormation template and say, this is exactly what I want, and do inspection against what you've configured in a template versus what somebody may have already created. And because it's also parameter driven, it gives you lots and lots of flexibility around what it produces. A lot of the questions I also get is, how is this different from Elastic Beanstalk? And the simplest way to describe Beanstalk in CloudFormation is, if I just want to run my application and have really no real need to access to the actual virtual machines or servers that are running it, I probably want to go with Beanstalk. But as my requirements grow, my capability and skills increases, and now potentially within the organization I am now allowed to do more with infrastructure, then I may want to move to CloudFormation where I want to control the entire data center, the entire environment, using my configurations. So think of Elastic Beanstalk as really a way of taking shrink-wrapped applications that you've built and have rapidly deployed to AWS. And think of CloudFormation as fine-grained declarative control literally over every single IP address if you choose to configure those, as well as disks that are attached, and any other fine-grained configurations that you wish to have set up in your virtual data center running on AWS. Having said that, I really also need to mention a couple of new services that have been recently announced at our reInvent conference about 2.5 weeks ago. These are very interesting, so let me just go top to bottom. We've announced something called Elastic Container Service, and the idea of ECS is to take essentially Docker configured and built containers and provide you, our customer, with cluster management and configuration services whereby you simply create your Docker containers. You tell us what the container requirements are, how much memory you would need to run, as well as how much CPU it requires, and you tell us that that is your requirement. You then call the service, and the service will then allocate a virtual machine that you've spun up already, and will push that to an appropriate virtual machine. So think of it as you spin up 4 virtual machines, you make those join the Elastic Compute Service. They become 4 nodes in your cluster. And then as you deploy your Docker containers, they will get deployed to each of those individual 4 virtual machines. If you run out of storage or capacity in your 4-node cluster, you can auto-scale potentially to add more nodes and then have more capacity to deploy more Docker containers. Even though we already support Docker as a part of Elastic Beanstalk, we only deploy a single container on a virtual machine. The difference with Elastic Container Service is that you can much more heavily stack your Docker containers on a single virtual machine, as well as having the benefit of Amazon taking care of the cluster management of multiple nodes. Another new service that we've announced, which is currently in limited beta with some customers, is called AWS Lambda. And AWS Lambda is very, very unique. Think of it as it's a compute service that runs your functions or runs small amounts of code. And it runs that code when certain events occur. As an example, if you were to do an upload of an image into AWS, or if there was an activity within your application, like a click or some other external event, you may actually need to run a small bit of code to do things such as on image upload, convert large image into a thumbnail. Traditionally, and still today, you would be running generally a virtual machine, an instance, that has a sole purpose in life of potentially collecting those events and doing a transcoding from a large image to a small image. Because it's a virtual machine and we charge on a per hour of compute basis, you will be paying for a compute hour whether that virtual machine has done work or done no work. In the case of Lambda, we will only charge you for every 100 milliseconds that your application code runs, which is very, very different and very revolutionary from the traditional model. So if you have very few image uploads, you only pay a fraction of a cent for those functions to execute, as opposed to paying a couple of cents per hour. So it's a very, very different model, and it's also, think of it as an evolution into a microservices or stored procedures or macros that you can run in the cloud against certain events or functions taking place at a fraction of the cost. And finally, the ones that I'm really excited about, if I wasn't excited about Lambda, I'm really excited about code commit, code deploy, and code pipeline. These three new services are looking at application lifecycle management. Think of it as code commit is essentially a very highly secure, highly robust Git repository run on AWS. So if you're using Git for your source control, for your check-ins and check-out and feature branching, that's great. You can now use code commit. So source control in the cloud, which can then connect with code pipeline. And think of code pipeline as a continuous delivery and release automation service that aids in the actual smooth deployments and workflows associated with your code commit. As an example, when you commit your code into code commit, so Git, we could certainly take that code and then put it through code pipeline and go through a workflow process which might spin off certain activities like automated builds and potentially spin up automated code deployments to your environment, which is exactly what code deploy is about. So code deployed is a service that automates the deployment either to a single machine or a fleet of machines running on EC2. So think of this now as Amazon provides you with a lot of the plumbing required for application lifecycle management. You can still choose to use any IDE environment you have today, be it Vi or Emacs or Visual Studio or Eclipse. Check in that code into source control via code commit, have code commit then trigger off code pipeline to do automated builds and the continuous delivery mechanisms and deployment mechanisms via code deploy. So it becomes quite an interesting scenario for us. So hopefully I've managed to scratch the surface on some of these potential migration opportunities. So we've talked about, just to recap, we've talked about a plan, a strategy to migrate into AWS, the 6 steps of consideration and evolution as to how you might tackle your migration. We've also spoken about the various design and migration patterns for your applications, be it horizontal migrations, which allow you to move tier by tier, or potentially moving and applying a bit of a lift and shift model via vertical migration, where you move applications and the associated stacks simultaneously as one. And we've also covered a number of options here. We've talked about the 4 around do-it-yourself on EC2 deployment mechanisms, just like you're potentially doing today on-prem. Talked about the automated environment deployment via Elastic Beanstalk. Talked about the layered options by using OpsWorks and providing and using and potentially reusing your own libraries of chef recipes. And in fact, there's a large number of chef recipes available on the internet. You could certainly look for those and also bring them into your repertoire and library of recipes to further extend your application stacks. And finally, spend a bit of time on DevOps around using CloudFormation, where you can declaratively describe the entire data center down to the IP address and configuration of your machine. So I hope that's set the scene for potential opportunities for you to migrate to AWS. And I've only managed to scratch the surface on this. So I hope in the remainder of the session we can cover off some questions, which have been coming through thick and fast. But before I do that, I want to thank you for taking part in this webcast. It's also very important to us that you provide us with feedback. Let us know how we're going. Let us know how, whether I've met your expectations, and hopefully provided some valuable input on your potential migration options. As well as, like I said, I can only do so much justice in about an hour. So I would also encourage you to consider some online or formal training as well as certification. There's a lot to be said about the AWS Cloud. I've hopefully given you some idea of some of the services that we have, but we have over 40 of them. So there's a significant amount of richness, breadth and depth in the platform. And some of that can be accelerated through formal training, online training. And also, once you've covered that, it's also great to get certification to show your badge of honor that you do have the expertise to be able to deploy, manage, and operate applications in the cloud. So thank you so much. I'm going to look over to some of your questions that have come up in the background. So bear with me while I quickly scan through some of these. We do have about 10 or so minutes, so I'll see if I can do justice to what we're doing here. Let's have a look. Scroll to the top. So one of the questions is, what are the various AWS components available for DevOps, and how are they different? So DevOps essentially is, it's really a process. It's a way of building software. It's a way of automating a lot of the manual activities that have evolved over the last several decades in the IT industry. So DevOps has a number of components. So one of those common components would be having source control. So you would have source control to check in your code. You would then have some kind of a continuous integration server that would draw the source out of your source control environment and potentially go off and create the environment for you and do automated builds, automated tests, and provide you with potentially visual feedback on how it actually performed and how successful it may have been. And then there's also the element of deployment. And CloudFormation is very useful here as well, because quite often the deployment piece was done manually or via automation of scripts inside running pre-existing and pre-configured virtual machines or physical machines. The beauty of CloudFormation is now you can spin up an entire data center just when you need it. So you could spin up an entire data center, build your entire architecture, then do some stress testing against it, throw millions of requests at your load balancer and see how your application performs and track that for 15, 20, maybe even an hour, and then shut the entire environment down and have those results delivered to your inbox in the morning for the continuous integration server to say, here is the environment, this is what you got, here are the creaky parts of your stack. So it's really an end-to-end process, and CloudFormation, source control are very small components of that. Fundamentally, a lot of the heavy lifting still goes back to the developers around test-driven development and any other activities that you need to sort of engage upon to make sure that you've got quality in your code before you ship it into potentially production. So that's a great question. Thank you. Okay, I've got a question around databases. Can you export database contents and import these into IDS MySQL instance? So there are a number of options for actually moving a database into AWS. So if we're talking about the relational database as a service, and we're talking about the MySQL engine, you have a number of options, in fact. You can do a binary export of your MySQL database on-prem or from your laptop, and then do an import directly into the IDS instance on AWS. You could potentially, if you're using MySQL 5.6, you could set up a read replica as a part of IDS and then replicate into AWS from on-prem, whereby there would be no disruption potentially in the migration of data or your application if you were to flip the switch from the on-premise database to the MySQL database on AWS. Or you could spin up MySQL on an EC2 instance all by yourself, as you would have done in the past, as a part of your general deployment, and manually copy and deploy everything yourself. So there are a number of options. But certainly, moving your data certainly is an important one, and does require a bit of forward planning, primarily because, like I said, data is king, and it has gravity, and whatever happens to it affects your application. A couple other questions. Can you migrate Windows-based .NET applications to Amazon? Not web-based, but Windows-based. Absolutely, yes. So the question is probably around building applications that are not just websites. Yes, you certainly can. When you spin up an Amazon virtual machine running Windows, creating an instance, you basically can IDP into that machine just like you would traditionally IDP to remotely access your machine from home or in your data center. It behaves the same. You can take your MSI packages, traditional applications, as you have in the past, and deploy them on AWS. You can have that Windows machine become a member server of Active Directory. In fact, Amazon offers Directory as a service. It's one of our other services which we released quite a number of months ago. And that Amazon Directory service can then connect to your Active Directory on-premise. So you can become a member of that, or actually replicate your AD into AWS. So you can even have single sign-on experience logging in remotely into an instance on AWS and have an exact experience that you would traditionally experience within your own data center or on-premise. Another question. I have 300 to 400 applications of J2EE. And what's the approach to move to AWS? Do I do a lift and shift, or do I do a reconfiguration of the application? That's a great question. If you have 300 to 400 applications in J2EE, it really depends on the nature of these applications, any dependencies that may actually exist between them, any dependencies on potentially a database or environments. One of the options, like I said earlier in one of the first few slides, was you could create a bridge, so essentially create a hybrid cloud whereby you connect from your data center into AWS and gradually move the applications that are the best understood, the simplest to move, and potentially move them as, vertically, so as individual applications. But also, if these apps do have sociability elements and, dependencies, have a look at moving each of those individually on a horizontal sort of migration path and closely watch the network latency elements, because latency is one of the biggest challenges you have to deal with, and quite often you don't know what they are. So you certainly could try it that way, but with 300 to 400 applications, I would suggest perhaps it wouldn't be a bad idea to contact AWS, speak to one of your regional architects. The friendly architects even come with their own whiteboard markers, so we'll quite happily sit down with you and whiteboard a strategy and an approach. But with that many applications, I would say you probably want to start running a large Excel spreadsheet and get a really good handle on the dependencies and configurations. But fundamentally, you can move any x86 workload that you have on-prem to AWS, whether it's on Linux or Windows. It really makes no difference. We support that. All right, just looking for some more questions. What is the difference between the above? Okay, what's the difference between all of the above? Okay, interesting one. So those services I spoke of, fundamentally the idea is that you can be as fine-grained as doing things on a single virtual machine, on an instance on an EC2, in the EC2 cloud, or you can look at services that we've put together that essentially take care of some of the heavy lifting that you would normally have to manually go through. And the intention has been to give you the ability to get a higher velocity and spend less time working on the things that are often repeatable. So whether it's Beanstalk or OpsWorks or CloudFormation, each of those services has a particular set of use cases. And it really, like I said earlier, comes back to understanding, who you are, what your responsibility within the IT organization, and as developers, figuring out whether you want to be, focusing purely on your application and using Amazon to provide you essentially a platform as a service offering for things like Beanstalk and OpsWorks, or you want to be infrastructure heavy focused, which is things like EC2 and CloudFormation. So I hope that sort of tends to provide you another facet of looking at how all these services come together. And from the looks of things, okay, another question. Is there any rapid deployment tools that allow physical to virtual and vice versa? There is actually a large number of tools out there. I would say, have a closer look at the actual virtual environment you wish to go to first. For example, Amazon, when you deploy our command line tools, we provide you with tools that can take virtual machines that you've already got on-prem, whether they're Hyper-V, Open Virtual Appliance, or VMware, and you can simply run a command line tool and have those imported into AWS. In fact, we've even got plugins for vSphere, whereby you can simply click on a virtual machine and have that virtual machine automatically be moved over into AWS. But to move from physical to virtual, I would say have a closer look. There's a raft of things that you could do. You could, on Linux, you can just use DD to copy entire volumes from physical to virtual, and you can even go directly from on-prem into AWS. Another question which is following up, and where would the VMware connector for AWS fit in within these services? And are there any white papers on this? Yes, certainly. If you go and grab the VMware connector, the VMware connector really is around trying to assist our customers in rapid migration. So by deploying the connector, obviously that could be challenging in some cases because as a developer you may not have access to the console or permissions to install that software because it's actually an add-in. If you do, that's great. It's really meant to be a one-click deploy into AWS. We certainly can share some resources with you. If you just, I would say, go to Google and look for VMware connector, you will find a raft of documentation on how to do that. Okay, another one. I have 3 databases connecting to an application locally. Is it possible for us to use AWS Beanstalk to connect one application to 3 databases? You certainly can. When you deploy your application via Beanstalk, you can point your connection strings to whatever IP address or DNS record that holds your database. Whether that happens to be still in your physical data center on-premise, or it's scattered across the internet, or it's in the AWS Cloud, it really doesn't matter. It's simply just a connection string as far as the application is concerned. All that Beanstalk will do is it will give you the ability to deploy your app. If you chose to deploy a database via Elastic Beanstalk, what that would then give you is we would pass in the environment variables that hold the name of your IDS instance, the database. And you could then pick those up from the environment variables for your application. So hopefully that helps to answer that question. A few more. How is OpsWorks different from code deploy? Okay, that's a good one. So OpsWorks really, as I said, is meant to be a way of deploying applications as tiers and use Chef to automate and configure the environment, to a deeper degree. Code deploy is really about deploying, once you've got a fleet of machines deployed via OpsWorks or via other mechanisms, is to be able to then deploy your bits, be it application or binary data or configurations, to a fleet of Amazon machine images. So certainly you could use this as a complement to use those 2 services because they are complementary. Another question, does RDS have Oracle? Yes, we certainly have Oracle. We are actually the only provider that gives you access to Oracle by the hour. So if you need to spin up Oracle and do some experimentation as for a small POC or for a project, you don't have to spend the money to buy a full Oracle license. We will certainly charge you for Oracle based upon the hourly consumption. So if it runs for 24 hours, we'll charge you for the 24 hours. If you run it for an hour, we'll only charge you for that 1 hour. Another question, what tools can DevOps use to automate WebSphere cluster deployments and configurations? Wow. Well, WebSphere is its own platform fundamentally. So you certainly can do a few things programmatically. So DevOps really would be, you would have to look at the tool chain, so the tools that you've chained together to give you a certain outcome. So as a part of those scripts, you certainly, depending on what you're trying to achieve with WebSphere and how you're trying to automate it, you would then potentially make programmatic calls into WebSphere. But most likely, seeing the way that WebSphere has been set up, depending on your licensing, because there is obviously a licensing element. If you want to scale out WebSphere, obviously there are license implications. What a lot of customers also often end up doing is try to vertically scale the application, which also may incur some licensing for you as well. So you have to be very careful to sort of make sure that while you can auto-scale and while you can use DevOps tools and tool chains to give you some additional control over your entire environment, there's also the somewhat unfortunate component, which is cloud economics and associated costs that go with it, whereby your infrastructure configuration can result in larger licensing fees. Another question. Well, there's quite a few that's coming in. One final question before we wrap up. Can you deploy Active Directory on EC2? And if so, can we keep that instance in the same subnet as a local office? So the answer is yes. As I said before, you can deploy Active Directory via the Amazon Directory Services, or you can take a Windows instance and promote it to be a domain controller and have it join the existing Active Directory forest or domain. but can you have it on the same subnet? The answer is no. When you spin up an AWS environment, we will, when you're spinning up the virtual private cloud, so the virtual data center, we will ask you for a particular IP range. And you can certainly use the same IP range that you have on premise, but your routing will probably not work because you can't have IP ranges overlapping for routing to work, unless you do some very clever and tricky natting between the cloud and your on-prem infrastructure. So you could do it. I certainly wouldn't encourage it because it does make routing complicated. I would say, use AD and AD sites to maintain control. And I think if you're looking for group policies, make sure you assign those sites and domains based on their own IP ranges. So, folks, thank you for your questions. I really appreciate the engagement that we've had in this session. We are at the top of the hour, and I am somewhat 5 minutes over time. So thank you for joining us, and please provide us with some feedback, and I look forward to hopefully meeting you all in person one day. Take care.